Hello, my name is Katie and this is Interactive Concept 7, and today we'll be talking about electron domain geometries. So to start, I'm going to show you what a trigonal planar electron domain geometry looks like with balloons. So I chose to use SO2, and this trigonal planar geometric shape has 3 electron domains with 1 lone pair. So the lone pair would be right here. So if you imagine maybe there's 2 little dots right here specifically for SO2, and then you have your 2 oxygens and your sulfur. So this one's the first one, trigonal planar. And then I'm going to show you tetrahedral with balloons. So I didn't have quite enough balloons, so I'm going to be putting on the next balloons for this one. So tetrahedral, I would have another one down here. So I'm doing CH4. So this is a hydrogen, theoretically. So we have 3 hydrogens, and then we need 1 more for tetrahedral shape. Would go right up here. So you can see I have 3 hydrogens on the bottom, or it's all equidistant all around the central atom of carbon. For this specific model, there's no lone pair. This is tetrahedral, no lone pair for CH4 with 4 electron domains. All right. And of course, all your hydrogen atoms would be the same size, but that's what it'll look like structurally. Okay, so next I have a trigonal pyramidal T-shaped, specifically, electron domain geometry going on here. So for this one, you can see it looks like a T. We have 5 electron domains here with 2 lone pairs. So there's going to be 2 lone pairs on this central atom, and that's what gives it this T shape. So for this one specifically, I did CIF3. So you have the 3 fluorides, and then you have your central chlorine here. I'm sorry, chlorine, not CI, CL. Just reading my notes incorrectly here. So we have Cl here with the 3 fluorides around it, and that's giving it the T shape, and it has its lone pairs here on the chlorine. So 2 lone pairs in the trigonal bipyramidal. So next we're going to have octahedral, and I chose to do XEF4 for this one. And so it'll have 2 lone pairs and 6 electron domains. So for this one, again, I didn't have enough balloons, so I'm just going to construct it now, what it would look like. So you would have opposite the other. We'll add on our, yep, there we go. So we've got an octahedral here with 6 electron domains and 2 lone pairs. So the 2 lone pairs around the central atom is what's giving it this shape here. If it didn't have those lone pairs, we would have 2 more atoms around here. 2 more atoms around here to be that octahedral shape. All right. Well, this specifically is a square planar within the octahedral because it has those 2 lone pairs. Okay. So next I have carbon dioxide, CO2, which is going to be a linear model. Get this one works for linear. Take that extra atom off. All right. So we've got linear here. Well, it needs to be straight. Okay. This is linear here. So for this one, it's 2 electron domains in your linear model here. And for CO2, you specifically are going to have 4 lone pairs, and they're going to be around the oxygens here. And you'll actually have 2 double bonds between the carbon to the oxygen here. And this is showing a linear electron domain geometry. All right, so we went through trigonal planar, And it was specifically, it was a bent one. Bent like this because it had that lone pair. The tetrahedral with CH4, the trigonobipyramidal with ClF3, and then octahedral with XeF4, and the linear finally with the CO2. Yeah, so pretty cool to see that in physical form, and thank you for watching.